As you can see here, this is the elemental analysis that we got from Gabbard Laboratories. You have the percent PDAC in the EVAC copolymers that range from about 9 to 100. We got the percent carbon and the percent hydrogen from Gabbard, and we determined the percent oxygen by difference. The percent PDAC that we calculated was found taking the percent oxygen by difference and dividing by what you would find in 100% PDAC. This it makes sense because as you're adding more PDAC into the copolymer, your percent carbon is decreasing where your percent oxygen is increasing, and you'll see it in the structure of PDAC why that happens. So this was our EVAC calibration curve. It showed our experimental percent of PDAC versus our theoretical percent PDAC, and it gave us a strong linear correlation with a correlation coefficient of 0.99. Here's the FTIR spectrum of the high-density polyethylene. So with this spectrum, we found that there were 4 peaks that were characteristic of PE. They were at 2914, 2847, 1470, and 718 reciprocal centimeters. This highlighted peak here is the 1470, and it shows the methylenes within the PE. And here's the 720 peak, and it's the chain of methylenes. This is our spectrum for the GB30 polyvinyl acetate, and our key absorbance peaks here were at 1728, 1433, 1370, 1224, and 1016 reciprocal centimeters. The 3 that we chose, or that we found were the most characteristic of PDAC, was 1728, 1224, and 1016. So here you have the 1728 peak, and that represents the carbonyl, the carbonyl of the acetate moiety. Here the highlighted peak at 1224 represents the ether of the acetate moiety, and here at 1016 just kind of shows the acetate in general. We ended up focusing for our results on the 1224 peak.
Yep.
So this was our EVAC copolymer. It was one of our examples of 33% PDAC. And here you can see that the 2 highlighted peaks are the ones we chose to focus on. We got the best results for. And they're at the 1467, which again represents the methylene in the PE, and you have the 1235, which represents the ether of the acetate in PDAC. You can still see that the 1736 peak, the 1020, and the 720 peak are still there. That represent the carbonyl, the acetate, and the chain of methylenes. So this was the 3 ratios that we looked at originally. Our percent PDAC still stayed the same from 9 to about 70. Our first peak area ratio for the absorbances was 1236 and 1467 reciprocal centimeters. Then we had 1020 and 720 reciprocal centimeters, and 1735 and 720 reciprocal centimeters. So looking at these graphs, they show that the peak area ratio versus percent PDAC. The 1020 comes from the PDAC, whereas the 720 comes from the polyethylene. You have the 1735 that comes from the PDAC, and the 720 that comes from the polyethylene, and the 1236 that comes from the PDAC, and the 1467 that comes from the polyethylene. Looking at these 3 graphs, for the first area ratio, we only got a correlation coefficient of 0.84. For our second ratio, it got a little better with a correlation coefficient of 0.93. But as you can see that this graph, using the ratio for 1236 and 1467 reciprocal centimeters, we got a correlation coefficient of 0.98. So the second part of our study was for the PDP-PDAC copolymers. And this again is the elemental analysis that we obtained from Gabbard Laboratories. The percent of PDP ranged from 30 to 70. We got the percent carbon, percent hydrogen, and percent nitrogen from Gabbard Laboratories. And again, we determined the percent oxygen by difference. The experimental percent of PDP was determined by taking the percent nitrogen found in each copolymer and dividing by what you would find in 100% PDP, and it was around 12. carbonyl within the 5-member nitrogen containing ring. You saw this slide previously. This is just the 100% PDAC with the 3 peaks that we focused on originally, and then narrowing it down to the 12-24 because it gave us the better ratio, which you saw. This is one of our examples of 50% PDP in the PDP PDAC copolymers. So the 2 highlighted peaks is the 1668 and the 1231. The 1668 comes from the carbonyl here in the nitrogen containing ring, and the 1231 comes from the acetate, the ether of the acetate moiety in the PDAC. You can still see the other peaks from the carbonyl at 1730 from the carbonyl in the acetate. 1020 would be the acetate, the whole acetate. So for this part of our study, we looked at 2 different ratios. Here you have the experimental weight percent of PPP ranging from about 30 to 60. And our first ratio we looked at was the carbonyl 1 from the PDP versus the ether ratio from the PDAC. And our second ratio was the carbonyl 1, which was from the PDP, and the carbonyl 2 from the PDAC. Based on these graphs, you can see that the carbonyl 1 versus ether ratio gave us a stronger correlation with a 0.96 correlation coefficient as compared to the carbonyl 1 carbonyl 2 ratio, which only gave us a correlation coefficient of 0.82. And part 3 of our study was the study of the blends made by PDP PDAC homopolymers. In this study, since we found in the previous study that the carbonyl 1 ether ratio gave us the stronger correlation that we were looking for, we decided to stick with that ratio for this part of our study. The weight percent of PDP for the blends ranged from about 20 to 80. And based on this plot, you can see that the ratio of carbonyl 1 to the ether versus the weight percent of PDP gave us a linear correlation of 0.94. So in conclusion, the FTIR methodology can be used to establish the percent composition of EVAC and PDP PDAC copolymers. The theoretical copolymer composition of EVAC and PDP PDAC corresponded to the experimental composition determined by elemental analysis. A stronger correlation for EVAC was observed between the 1236 reciprocal centimeters and 1467 reciprocal centimeter absorbance peaks. A strong correlation was also seen for the PDP PDAC, which was observed between the carbonyl 1 and the ether peak absorbance ratio. A linear correlation was observed in the blends for the carbonyl 1 and the ether peak ratio. I would like to thank the Hofstra University Chemistry Department, especially Dr. Lynn Wang, Dr. Ronald D'Amelia for taking me on and mentoring me with this project, and my parents, because without them I would not be at Hofstra.
We have about 3 minutes for questions, if anyone is done.
What practical application could you see of the development of these relationships between the infrared spectrum and these copolymers or these blends of these particular homopolymers?
Okay. Well, PDAC and PDP are found in a lot of commercial products, such as hair products that females and I guess some males do use, as well as adhesives. So this could be a way to quantify the percent of PDAC as well as PDP, in those commercially prepared materials.
Also, do you see any other extension of this kind of project that if you wanted to extend it, how do you extend this particular project?